am the founder of a company called Pinakastra Cloud. We are a Bangalore-based startup basically, primarily focusing on building private cloud infrastructures. So, just to give you a background of why we chose this area of domain to start us, because you will not find many startups working in this area. Mostly it will be all B2C, right? But we chose a hard way to start with, right? Network or servers and all those things. The reason behind is, initially if you see, we were all going by the narrative that public cloud is very attractive, very cheap, and all those things. Even enterprises, because if you look at the AWS story, right, they started this narrative of being public cloud is the future kind of narrative in 2006. But if you look at that narrative, from 2006 to 2011, nobody believed in cloud computing. I'm sure we are all same batch of people where we know what was the situation in 2005, 2004, 2010 and all. So till 2011, nobody believed that cloud computing will be the future, for sure. Because everybody had the feeling that why would I put my workload in somebody else's server, right? But slowly what happened is, that is the beauty of Americans. They will keep up that narrative until you believe. And it becomes a reality. So that persistence, right, is what we have learned from them. And they kept saying, and now you see, it's all cloud computing. Cloud computing, then it's advancing to quantum and all those things. I don't know what will come a decade later. But still, if you look at the startup ecosystem and all, now the very first thing in the checklist would be which cloud platform should I select, right? Any startup. So now that story became a reality. 2010 to 2024, things, everybody is into cloud. Now if you look at last 2 years, trend has completely changed. Even enterprises with large, deep pockets, they have started thinking. Earlier they were not worrying about spending in AWS cloud. Whatever bill comes, they used to spend. But slowly even enterprises have started thinking, why should we spend so much? Right? And especially after this AI, ML kind of workloads started kicking off, we know how much of cost it comes when you spin off a GPU instance, right? So even enterprises with the deep pockets have started thinking, why not having a hybrid setup, where we'll have a setup of our own, like private on our premise, and then we'll have public cloud also. We'll keep all business critical things in public cloud where it requires high scalability, and we'll offload all our auxiliary workloads to our on-premise. The major scary factor which people used to have in the early days was maintaining this hardware and all. Hardware used to be not so robust like what we have today. Even if you look at the servers and network equipment and all those things, right? Hardwares have gone well ahead by technology. Now if you switch on a server, in 2005 or 2004, I still remember sleeping in the data center. When we have to go for a Diwali vacation or something, we used to pray. That was not a meme actually. We used to stand in front of the server and say, please don't do a strike. We peacefully go home for vacation and come back. But those days have gone. You switch on a server, it keeps running. So that is the level of advancement in hardware technology has come. So now maintaining such an infrastructure in-house is not that big deal like earlier days. So this realization has come in enterprises also, because they are looking at what is the way we can save cost. So now it's like a holistic development. It's not like only cloud technology developed, hardware also developed, and people's the workload also has developed, because the demand for compute and storage these days is like ever growing. When it comes comes to artificial intelligence, and where we are talking about petabyte scale of data, right? So the technology has also evolved, the hardware has also evolved, the way we compute also has evolved, the way we deal with data has also evolved, everything has evolved. So now we have alternatives. Now alternatives, we need not rely on hyperscalers always. We should rely for high scalability, keep all your workloads which require high scalability in public cloud. Everything else we can bring it in-house. We can manage it. We save cost considerably. Also, we'll have the control, and we'll have different other factors. If you look at the static reasons, these are the reasons which I was explaining. At scale, public cloud is never very attractive. If you have 10 EC2 billions and all, you will not know the pain. But the moment it processes 500 VMs, 100 VMs, 500 VMs, 1000 VMs, then it's gone. And if you spin off GPU that instances, that is a story altogether different, completely different. You cannot imagine what is the kind of billing you have. Then auxiliary workloads, like CDOT itself will have hundreds of systems, internal systems, right? CDOT's customers will have all internal systems. Why do we need public cloud? Anyways, in government organizations, public cloud is a no-no. Always, I did not talk so much, but still I am giving an overall picture. So such use cases definitely a private cloud. Now the challenge in private cloud situation is the monopoly of VMware. Now we all know what is happening with VMware, the VMware story which recently has come out. So anybody who would like to tell something about this VMware happenings recently? Yeah, that is the top level story. That is one like that. Now what has happened after that is what is basically licensing that everything gone. I heard it has gone 10x to 15x. I'm not sure. That is what the information I got. 10x to 15x. The other main thing is the perpetual license concept is gone. Now it's all subscription. Either you go for a 1 year commit or a 3 year commit. So now people who have been comfortable with perpetual licenses, they are all now worried, right? And there is no alternative for VMware. Either VMware or you go for Nutanix. These are the two, and cost wise, both are not, they will not make people happy. So definitely the other option is to explore open cloud, definitely. So that is where we have been working for so long, wherein we want to liberate open cloud technologies, because if you look at the OpenStack based clouds, like OpenStack based clouds, many organizations are using as an alternative to VMware, and they quite comfortably using it as a production and large scale. I'm talking about large scale implementations. Even in China and all, even Chinese library uses OpenStack based cloud. And there are many retailers, many use cases are there. Academics, academia, then healthcare. Healthcare and all, they have restrictions, right? They have industry regulations where they cannot put anything on the public cloud. So definitely those are the use cases, those are the industries which are looking for alternatives. I'm sure CDOT will also have such customers, right? Within the government ecosystem, they will have so many customers who were relying on VMware. But now the story has completely changed. I should be happy about that story, basically, because it is, I think, giving us a chance to come out and speak. There are alternatives. Now, how these alternatives are benefiting is what if you look at the industry vertical or the use cases which is suitable for public cloud, all small use cases is fine. But the moment it comes to the private cloud use cases, the research organizations, healthcare, academia, all those use cases, it's always better to have a private cloud infrastructure. And we are here to give that confidence of how stable it has become. Because if you look at the OpenStack project itself, it started in somewhere in 2011. Now it's almost like 13 years, right? So 13 years and 80,000 people working. It's a community, right? 80,000, I think it is one of the largest open source community in the world. I am not aware of any other bigger open source community which is having more than 80,000 people. So it's an 80,000 people large community and it is evolving day by day. And if you look at their release cycle, right, it's 6 months. It is really unbelievable. Every 6 months there is a release. But unfortunately we cannot catch up with those 6 months release and it is not required also. So it's like you implement a particular release now, probably after 2 years you may want to upgrade. If you are looking for any specific features which has come in later releases, you may come. Otherwise, upgrading every 6 months is not recommended and it's not possible. It's very difficult. So if you look at, we have all these competitive landscape. If you look at Canonical, who has their own distribution, Red Hat has their own distribution, Red Hat has, and Easy Stack is a Chinese company, Savishai is a UK company, White Stack is from Canada, Bengaluru is where we have VMware and everything. So many people players are there. What we are looking at is competing with these big players. We are competing. Though we are a small company, we think okay. We are competing with large people. So that's the, and if you look at the architecture, right? So we have designed it in such a way that we have modular architecture. By design, OpenStack itself is a modular architecture wherein you can plug in a feature. If you don't want, you can remove it. So it does not disturb the core services for sure. So it's a modular architecture by design itself. On top of it, at the hardware level also, what we are trying to do is we are trying to give the flexibility of either going by converged format or a hyper-converged format. Both options. So if you look, because both formats have different advantages and disadvantages. If we know that we will not go beyond 50 servers or 100 servers, then it is better to go with a hyper-converged format. Beyond which there might be few networking bottlenecks and all in hyper-converged format. And in that case, we can go with converged format, which is the usual format of scaling storage nodes separately, compute nodes separately. So you don't need to have a limit on hyper-converged format. Because if you have a hyper-converged format, then you have to, even if you have a memory upgrade requirement, you have to forcefully upgrade the compute also. So these two things. Yeah.
We say there's a comparison with respect to private public for affinity models. Can you just elaborate that?
So if you look at this graph, right, what it is saying is, what kind of, see on the left side is, this graph helps the management basically. For example, if management wants to decide on whether to put your workload in public cloud or private cloud, this graph gives a clear picture. If you look at, if the use case is to just host a website, then obviously public cloud is the cheapest option. Spin up one virtual machine, host your website, done. Again, if you are having a CRM inside the organization, okay, why do you want to host it privately? You can subscribe for Zoho or that's in cloud only. In SaaS model, that's the, but in cloud only. You can just subscribe for Zoho or some other Salesforce. Any. So that's again public. You need not worry about hosting and all those things. But the moment it comes on the right side, right? It's not very clear. See, if you look at this, talking about data mining. Data mining means we are talking about large data, right? Large data, you have a large interest of data and then you compute, bring out some insights and a small data, but still egress network, your network bandwidth usage as well. That is where most of the customers want their figures when it comes to public cloud. Because when calculating things, people will not think about the network usage. They will think about only, okay, EC2 instance, this is the billing, okay, fine. Now when they try to bring out the data between regions and between availability, not availability, between regions and all, then in you will see the difference, right? And that will really cost a lot. The network bandwidth. That is where people miscalculate. So when you are dealing with large data, you are dealing with large storage, you need a lot of space. Okay, then you put a analytical engine there you need insights. Then you bring out the results, right, to the presentation there or whatever. All these things. The moment you have such use cases, right, data mining and you batch processing, then ERP, right? CRM is lightweight actually. Meanwhile, ERP means heavy, right? Heavy workload because it's having batch processing and lot of data. For example, if you look at Dell's cache to code system, right? ERP, which is based on Oracle ERP, it's a very heavy system, very heavy system. I forgot the number of transactions per second it has, but it is one of the largest ERP systems. Since Dell is hosting it, they don't know, they don't need to pay. If the same, if it is done in public cloud, it will cost a lot. Right? Similarly, if you look at big data analytics, you don't need public cloud. In-house, if you have a cloud platform, in-house, you have all your Hadoop, everything set up, easily you can push it in-house. Similarly, research organization. Research organization anyways will not put anything on public cloud. They are not supposed to put anything. Right? They have sensitive data. They will never put anything on public cloud. Private cloud. So this graph is just showing from what kind of use cases you can select public cloud, what kind of use cases you can select private cloud. This is actually helping the management to quickly decide, easily decide things.
Do you have some benchmark test for this many VMs on training and beyond that going to public cloud? Some benchmarks up to so many VMs it is able to go on to.
Nothing like that. Nothing like that.
You told that beyond the 1,000 and all
that is physical server side. When you talk about hyper-converged format, right? That, for example, this one server itself is considered to be having network, software-defined network, storage plus computing, all together in one. That is hyper-converged. So what happens is, if you go in hyper-converged format, beyond 50 servers like this, you will have bottlenecks with the network, storage network and all. That is a disadvantage if you go with the hyperconverged. We are very sure that, okay, now we have to go only maximum to 50 nodes or 100 nodes, then it's good. If we are going beyond 100, there are 700 servers and all, it is better to go with converged network. Where compute nodes will be separate, storage node will be separate. So your storage network will be segregated. You have a separate route for data traffic. Your management and control plane will be separate. So that condition will not be. That's what. Not VM. VM is like how many ever physical nodes you have, whatever is the capacity of that node, you can spin off that node. So there is no limitation. That hard limit is within the physical server. What processor you have, how much of cores you have, what is the how many sockets is filled, depending on what is the physical RAM you have, depending on that.
For VMs also, do you have any benchmarks like this up to this many VMs?
Yeah,
How to go
yeah, exactly.
on
How to calculate? I'll tell you how to calculate this. Generally, what happens is if you take the CPU, right? If you take CPUs, one core, one physical core you can show it as 1:16. That is, you have one core, you can show up as if it is having 16 cores available. Okay. So that is actually at the higher side. Nobody uses 1:16. 1:4 is maximum. That means if you have 12 core CPU or a 24 core CPU, 24 into 4, 96 vCPUs. That is how we calculate. So 1:4 range is like decent for production and all. Nobody uses beyond 1:4. But OpenStack can show it as 1:16. That is the secret behind the cloud. All AWS and all, right? They are giving you, if you shut down your VMs, your bill comes down, right? Run it for only 9 hours. Morning, if you switch it off, you have benefit, right? What it is doing, virtually giving it for others, right? So same concept. CPU to vCPU ratio is 1:16, which is worst case. 1:16 nobody uses. 1:4 or maximum 1:8. Similarly, when you consider RAM oversubscription ratio is 1:1.5. That means if you have 1 GB RAM, you can show it as it is having 2.5 GB. Okay. So, but when it comes to storage hard disk, it is 1:1. How much GB you have, how much TB you have, you can do that. So based on this oversubscription, you can create a benchmark saying in your current private cloud infrastructure, you can concurrently have so many virtual machines of this configuration. Particularly like 2 vCPUs, 4 GB RAM and 50 GB root disk divided by total what you have. The calculation which I told you, right? That will be the total calculation. And if you take one VM configuration, just divide by that CPUs and RAM, you know what is the count of VMs you can handle. Beyond that, it is not advisable. We have a mechanism to restrict it with the quota mechanism. Total quota beyond which you cannot spin off any virtual machine.
What happened to the network? How do you calculate the ratio for network?
Network, there is no such calculation. Network, there is no calculation. It is only up to limited by your NIC card and your probably top of the rack switch. And if you are using 25 Gbps or 100 Gbps fiber channel, it gives a better performance. Otherwise, you have 10 GB or 1 GB. So that we don't have such oversubscription between much for network. It is as similar to that storage basically. Whatever storage you have, that much only you can use. But the CPU and memory you can show as if you have all. Because how it works internally is, if you have one VM with 2 vCPUs and 4 GB RAM, you are not using, actually using full 2 vCPUs 100% and fully with 100% load. You might use 10%. Again, remaining 90% of that power is available, which usually you might not know, but behind the scenes it is given to some aids. So it's like one side, somebody else will pull the resource, and when you repair, you will pull the resource. So that internal thing is like invisible thing which happens. So that's the secret in actually storage. Basically in cloud, what we are talking about is consolidation, right? Ultimately, whatever server capacity is there, we have to use fully. That is the main idea behind it. Now, how this virtualized environment helps there is, now going one step ahead is Kubernetes. Even if you have VMs, still there is a chance that you are not utilizing it fully. Because in VM also you are not very sure that you are going to be using 100%. Right? That's why Kubernetes came. Now again, Kubernetes, I don't know what happened. Kubernetes comes, but that is the latest. So Pinakastra is also part of a inception program, NVIDIA inception program, where we have the benefits on if hardware is purchased from our side, right? So the GPUs, we get actually we get up to 20% rebate on various GPUs and for the base AMDs and all of things. We are part of this inception program where we work with NVIDIA also in their V-grid technology. V-grid is for like vCPUs, right? If you want to slice the GPUs and give it to VMs, we can do that. But the normal way of doing is PCA pass.
So apart from the regular hypervisor, the NVIDIA hypervisor also.
If you want GPU backed VMs, right? If you plan to have a AI workload or a workload, right? Probably you need a VM which is backed by GPU. And GPU can be offered in two ways. This is PCA password method. That is, if you have one GPU in the server, right? At a time, it can be attached to one VM.
So NVIDIA brand is the same NVIDIA virtualizer can be used on those GPUs.
So they have that certified hardware with
So different from like other vendors also the GPUs can be utilized in this NVIDIA.
no, if you look at the other vendors, the AMD and Intel, they have GPUs. I don't think they still have that GPU slicing. Only NVIDIA has. If you want to slice a GPU with the 80 GPU DRAM, you can attach it to 10 different VMs virtually. Right? But it is licensed. You have to get a legal license.
Does it work with any other hypervisor? Like
KVM it works.
VMware.
It works with VMware and I think Zen hypervisor also it works. Yeah, they support all of them. This is the other format where we have two different formats of deployment. One is the standalone cloud where within one region independently working. Two different regions working independently. But in case of distributed computing, there is so it's only architecture very different. Wherein there will be a central cloud and sub clouds. For example, there is a headquarters where we have the central cloud and we have to manage different sites from the central cloud. These sub-clouds also work independently as a separate cloud available to zone. But you can manage the configuration management, patching, security, all the fault management, alarms, and everything from a central cloud. So it's only talking about architectural differences, but the services are the same. These are the cloud deployment models which we are having. We give it as a distro or appliance, turnkey appliance, where based on the capacity requirement, we build the complete rack. We have AWS Outpost now, right? Where we build the quarter rack or half rack or full rack, kind of whatever capacity is required, build it, ship it, and deploy it. That is one way of doing. And we are also having a hosted private cloud. That is like a subscription based. The third one is AWS. So I am done with this thing.
Vishnu, can you